Hello and welcome to today's webinar. This is in association with Dries and Summer, and it's all part of our Net Zero Live event this week. My name is Chloe McCulloch. I'm the editorial director at Assemble Media, and the discussion for today is energy efficiency. It's all about looking at the future systems and technologies that will enable good energy efficiency in buildings. And we're going to look at some of the key challenges and how those can be overcome in the pursuit of net zero. So here to help us understand all of that, we have an expert panel. So we've got Marco Abdullah, Head of Engineering at Dries and Summer, Simon Wyatt, Partner at Condal. We have David Mason, Environment Technical Director at Skanska, Victoria Kate Burrows, Director Advancing Net Zero, World Green Building Council. And we have Peter Fisher, Director at Bennett Associates. So welcome everybody. Thank you so much for joining us from your various places of work. I just want to remind the audience quickly that during this webinar you can post questions at any point and we'll collect them all up at the end for a Q&A session. So please, if someone's said something really interesting and you want to hear a little bit more about that, just post a question and I will try and pick up as many of those as I can at the end, and we'll try to answer them for you. Also, you'll hopefully like to know that the presentations that you'll see today will all be available on demand after this session's finished. So if you have to drop out or have missed the beginning, or want to let a colleague know, this will all be available on demand on our website. So please do go to building.co.uk after this session. So that's probably enough for me. I'm going to ask Marco to do the first presentation, and if my other lovely panelists can turn off their webcams while he's presenting, I just have to make him a presenter, and hopefully it will be over to you, Marco, and you'll just have to unmute yourself, and hopefully it will all be working. Is that working for you, Marco?
Yeah, just hope that you see the right screen.
That's looking great. I'm going to turn my webcam off and over to you.
Excellent. Thanks, Chloe, for the introduction. It's a pleasure to kick off the first session today. We would like to show you the approach regarding energy efficiency in the context of zero carbon and how that can lead to plus energy buildings. It's a good start to always look into the scale of the problem of the topic we are discussing. Our construction sector has a huge ecological footprint. Our buildings are responsible for around 33% of the total carbon emissions and consume at the same time 30 to 40% of our energy. On the material side, it's even worse. Buildings consume around 40 to 50% of raw materials, and the construction sector in the UK is responsible for 60% of the waste production. However, that's another topic for another panel discussion. Focus of today is the energy and climate challenge. With energy efficiency, we directly address the operational carbon footprint. You see here a carbon life cycle assessment of a tower in London, which we analyzed recently, and you recognize those carbon life cycle assessments typically that around 40 to 65% of the life cycle carbon is operational carbon, and the other half, around 35 to 60%, is embodied carbon, which is related to the materials we use. So at the point where we complete construction, we already emitted around 60,000 tons for such a tower. To give you a scale, if you want to compensate that, you would need to run a wind park with around 17 turbines for 1 year. Compared to the operational carbon, which is around 5,000 tons per year, you would need to keep 2 wind turbines running throughout the entire lifetime of the project. To compensate operational carbon emissions, we address it with energy efficiency, and to compensate embodied carbon, we typically use circular economy principles. If we look into a carbon life cycle assessment, we can see that the carbon emissions are distributed over the life cycle of the building, with that initial peak of embodied carbon in blue color at the construction, and then in orange color a relatively constant band of operational carbon emissions. And again, I think the answer to operational carbon is to move away from fossil fuel, utilize on-site renewable energy sources, and look into energy efficiency. And I think we have the technology in place today to push it to zero for new buildings, and even to develop plus energy buildings. It's, I think, rather a lack of collective will. Technology in the end is there. A good example of a plus energy building is the City Hall in Freiburg. It's in Germany, a building we designed a few years ago. It's now completed, and the plus energy case has been measured and verified by a third-party institute, the Fraunhofer Institute, which did an independent assessment. And one key strategy was to activate surfaces which are exposed to solar radiation with photovoltaic cells and integrate that into the architectural concept. And that led us to those so-called solar fins, which you see here on the screen. We have photovoltaic cells mounted on a timber panel, which is sourced from the local region. And the fins for shading are fixed. Originally, they were meant to turn with the sun. However, due to maintenance and invest, we decided to fix them. And we calculated the best angle regarding daylight supply, shading, and solar harvest. And with those fins, with that feature, the building is now able to produce energy on site. Temporarily, the building still consumes energy. It's not an autarkic building, so it needs the connection to the grid. And on a cloudy winter day, -10 degrees, with no sun, you will still need to heat the building. You need to take electricity from the public grid. However, on a spring day with a lot of sun, you will be able to produce more energy than you need. And over the annual balance, you can show, or we could show in that case, that we produce more energy than we need. And that's the reason why we can call it a plus energy building. So it principally, when it relates to carbon emissions, it would even compensate carbon emissions and provides clean electricity for the neighborhood. And to achieve that, we developed a holistic energy and room climate concept, combining different measures. The first step is normally to develop a high-performance building envelope with the solar shading fins and a highly insulated facade, which brings the energy demand down to 50 kilowatt hours per square meter per year. And then the second step is to develop a room climate concept which fits to the envelope. We used here a hybrid ventilation approach with the possibility of seasonal natural ventilation, and together with radiant heating and cooling through building mass activation. So we have water pipes in the concrete slab, and the concrete slab can be cooled in summer, which absorbs the heat from the space without any fans. So it's a passive approach. And the third step is then normally to develop the energy concept, utilizing energy, renewable energy on site. We have seen the photovoltaic panels on the roof and in the facade, plus we use geothermal energy for heating and cooling. And I think the important thing to say is that these energy efficiency measures, they pay back. The overall amortization period in that project of the additional invest cost we had was 6.5 years. So it means that considering the full life cycle of the project, we would save money compared to a conventional approach. So we consequently go this route now, and we also design our own headquarter in Germany as plus energy building, and go one step further. We want to combine it also with smart building approaches. And again, I think it's a very similar approach. We have here a very moderate window to wall ratio, and an external shading, which is flexible. In that case, we use triple glazing and insulation quality according to the Passive House standard. We have green walls to provide passive cooling to the interior space, and the remaining heat and cooling load is then absorbed by radiant heating and cooling panels, again passive without fans, and that is supplied by a hybrid heat pump which can take the which can run on the air. So it can be an air source heat pump, but it can also take energy from the ground through a ground source energy solution. And again, to offset it on site, we use photovoltaic cells, which we integrate into the roof. However, that's not enough to fully offset the energy demand, so we also integrate them on the south and west side of the facade. So in the end, it's not rocket science. It's really just to develop a holistic concept, to bring together the right approaches and the right measures. And for us, the path to zero carbon always starts with reducing the energy consumption, avoiding carbon emissions through shading measures, through natural ventilations, passive heating and cooling approaches. And then we typically look into renewables on site. That can be photovoltaic or geothermal energy, as shown in the example. Sometimes also wind is possible. And the last step is then offsetting. Unfortunately, we see that many projects currently skip the two first stages. They directly go into offsetting because that's really easy. But from our perspective, it's not the way to go, because we would simply outsource the energy and climate change problem we have in our building sector to the utility sector. And what we actually need is to solve that challenge. Thanks very much for your attention. I'm looking forward to the discussion, and Chloe, I give you back the screen.
Thank you very much, Marco. In fact, we're getting lots of questions in already, so thank you to the audience for that. Keep them coming, But there's one specifically actually for you, Marco, that's come in from Andy, just asking about the nature of energy positive buildings. And he's just saying, surely at times in the year they generate excess electricity. So what do you do with that? Where does that energy go?
So in those cases, we feed it into the grid, because the grid is kind of an external buffer. But we also look more and more into local storages. So large-scale batteries. We had we worked on a master plan project where we had several buildings, and there it was then even economically viable to set up a battery storage system. I think for smaller buildings, it often turns out not to be economical, and then you rather use the grid. But it definitely will become more and more an option to have that in the future.
Okay, thank you very much for that, Marco. Right, I'm now going to invite Simon Wyatt to join us and share his presentation. So Simon, I'm going to try and make you a presenter as well. So here we go. And then me and Marco are going to disappear.
Can you see my presentation?
That's looking good. I think you just need to pop it in presenter mode, and then it should be a bit bigger.
Yeah, sure. Okay, good afternoon, everyone. My name's Simon Wyatt. I'm a partner at Cundall Multidisciplinary Engineering Consultancy. And I'm going to talk about net zero carbon buildings, but just to start with, I'll give you a bit of background on Cundall. So we are a multidisciplinary engineering consultancy, and we've been on our net zero carbon journey for about 10 years now, when we signed up to be a One Planet company in 2011 and 12. We last year trialled to become carbon neutral in Australia, and we just applied that across our global business and have been certified last month by the Carbon Trust to be carbon neutral across all three of our scopes. And we are working towards our target to be carbon positive by 2025. And it's been really useful learning how to reduce our own carbon footprint so we can apply it on our projects and with our clients, both at corporate level and at building level. This is our trajectory. So you can see, as indicated by the last speaker, Marco, that we've been looking at energy reduction strategies, purchase of power around our scope 2 emissions, and then phasing out fossil fuels. We've also have really challenging science-based targets, which are absolute reduction targets. So we're not just offsetting, we are reducing our impacts and then offsetting any residual emissions which are left over and trying to reduce those over time. In terms of net zero carbon buildings, we've been working on a number of projects similar to Marco's, which you showed earlier. But what's really important we've been focusing on is trying to get a global standard of what net zero carbon actually means, and working with the World GBC and UK GBC to actually frame what net zero carbon is, so there's a consistent benchmark. And the UK GBC framework, which came out just over a year ago, has really set the standard for that, and as it's on the screen at the moment, and outlines what we mean by net zero carbon. So it's reducing construction impact, reducing operational energy, increasing renewables on-site where possible, then off-site where not, and then offsetting any remaining carbon emissions. And all of this needs to be publicly disclosed. But what I'm going to talk about today is the first two, which is the construction impact and operational energy, because what we don't want people to be doing is just jumping to the offset, as the previous speaker was talking about. We need to have clear targets on what reducing your construction impact is and operational energy is. So there's been a lot of talk about intensity targets and setting operational Paris-proof targets in line with a 1.5 degree scenario. And the way that that's been done in the UK and a number of European countries now is to look at what is the amount of renewable energy we can produce as a country and versus our demand. At the moment, we only produce about 20 to 30% of the energy in the UK from renewables. In order to be a completely net zero carbon economy, we must increase the renewables that we produce, but also decrease the energy consumption on the grid. And if we reduce equally all sectors of the economy, it equates to roughly a 60% reduction in our operational energy requirements for buildings. And other sectors will actually find it more difficult to decarbonise. So achieving that 60% might not be enough for the construction industry. We might need to go down to a 70% reduction. So these aren't minor tweaks or energy efficiency programs. These are complete system changes on how we actually go about designing buildings. And as we reduce our carbon, operational carbon, and the grid decarbonises, the importance of embodied carbon, the carbon associated with the construction of the building, becomes more important over time, and we can't ignore it any longer, and we must start to consider it. When we talk about embodied carbon or whole life carbon, what we're talking about is all the materials that go into building a building, so their extraction, process, transportation to site activities, all of that's classed as your upfront embodied carbon. Then during the building's life, you have its in-use carbon, which is maintenance, refurbishment, repair. And then at the end of its life, it's deconstruction and hopefully reuse of materials using the circular economy. All of these need to be considered and targets set at the beginning of a project. In terms of embodied carbon, again, there's Paris proof of methodology. At the moment, the average building in the UK is over 1,000 kilograms of CO2 per metre squared. There's numerous energy and carbon intensity targets being set at the moment around about the 500 and 300 mark, which show a significant reduction required. And this graph on the screen is something that we did with the GLA, looking at embodied carbon of some of the best performing buildings that have been built in London recently. And you can see that most of these are significantly above that target. It's a really challenging target, and again, needs systems changes on the way we actually go about designing new buildings. So what we've done at Cundall is we've taken a lot of the frameworks that we've been working on with people like LETI, UK GBC, REBA, and we've put together what we call our 7 steps to net zero carbon, focusing, as the previous speaker was talking about, passive design, getting glazing areas correct, looking at natural ventilation, insulation levels towards passive house, reducing energy consumption and doing detailed analysis and control strategies, removing fossil fuels where possible and providing renewables on site, and then looking at power purchase for any remainder. Again, the examples of energy positive buildings are mostly 2 or 3 story buildings. That's quite an impressive energy positive building at 6 stories we've just seen, but when you're in urban environments, it's much more difficult to achieve that with the footprint of a building. So off-site is an option, especially in dense urban environments. Also looking at limiting upfront embodied carbon, but also considering whole life carbon. So a solution might be low carbon on day 1, but it might need replacing every few years. So we need to think about it in the lifetime of the building, either over 60 years or ideally over 100 years. And then transparency is going to be key going forward, that we're able to report transparently what we're doing, so it can be independently peer reviewed, so there isn't greenwash and it's all moving in the right direction. Over the last year, we've seen a real drive around net zero carbon, but almost 95% to or greater of the attention has been on new buildings. but the problem we have is that the net zero carbon target for 2050 is for all buildings. And if you think about 2050, 80% of the buildings that we're going to be occupying in 2050 are already built, and we really need to start focusing on existing assets. So what we've been doing with a number of large portfolio owners is going into their existing assets and reviewing their assets against these 7 steps and setting pathways and trajectories to reduce their carbon emissions. So scoring it against the net zero carbon criteria and making recommendations on how they can improve that. Key to this is understanding where their current footprint is, and most buildings in the UK energy intensity is over 200, and getting down to the UK GBC or LETI target of 55 is an extremely challenging target, and it needs to be done over a period of time generally. So what we do is we look at individual interventions, see how we can remove fossil fuels, and then look at things like replacing with electric systems, heat pumps, improving fabric, going to natural ventilation of openable windows, looking at behavior change and engagement with the occupants. The problem here is that there's no silver bullet. Technology will not solve the issue. We need to optimize the performance of all buildings to the best that they can actually achieve on all systems, and that takes time. For a new building, you have a budget and you can do it all in one go. For most existing buildings, they have sitting tenants, they have existing plant, existing fabric. So it all needs to be factored into the plant replacement strategy. It needs to be thought about when to replace the fabric, when to replace services. A good example is where you have a heating system. If we want to remove natural gas boilers, it's very easy to go into the boiler rooms and replace those for heat pumps, but they're generally not always compatible with the heat emitters in the space. So you have to understand when leases are coming up to the end of their life, when tenants are moving in and out, and take the opportunities when they arise to do these works. A lot of our clients want to be net zero carbon by 2030, but they've got sitting tenants till later than those dates, and it's going to be extremely difficult to do so. So every building will have its own unique pathway of when these intervention measures will be done in order to achieve the targets. Just finish up with some of the quick wins and key considerations. So it doesn't need to be too daunting. There's lots of little things we can do, like LED replacements is a simple one. Controls, far too many buildings we go into have simultaneous heating and cooling because they've got the set points at both 22 degrees for the two. And you have one zone heating next to one zone cooling, wasting significant energy. So just resetting controls and fine-tuning the control systems can save up to 20 to 30% in most buildings. But then if we're looking at long-term interventions, the key ones you've seen in the case study we just saw, optimizing those glazing areas, improving the fabric performance, moving towards mixed mode ventilation where possible, and relaxing set point temperatures to actually reduce energy significantly, and providing renewables where possible on site. So these are some of the key considerations we're seeing with lots of clients at the moment. So that was a quick tour of what we've been doing over the last couple of years around net zero carbon. And again, really interested to see what your questions are at the end.
Brilliant. Thank you so much, Simon. That's a whistle-stop tour, I'm sure, and it feels like there's a lot of depth within each of those points. So I will encourage all of the audience to post questions. I know there are questions coming through now, but I think we'll do a bit of a roundup at the end for that. So next on the list, we've got David from Skanska. So David, I'm going to invite you to come up, and I'm going to try and make you a presenter. So hopefully that's coming up now.
Yes, excellent. Thank you. Let's just get this up. Brilliant. Okay, thank you very much, and good afternoon, everybody. I'm going to come at this from a slightly different angle. We're going to look at it as far as overall company, what it means to a construction building contractor, and then talk about some of the energy efficiency challenges we have, and look at some examples that we're putting in place in the areas where we're working. So back in 2009, Skanska set its net zero emissions targets to be net zero by 2045. It's covering our whole business, all our operations, all our projects, and most importantly, it's covering the activities of our supply chain. The aim of doing this is to really demonstrate what it takes to deliver our construction revenues in a year. So to show and highlight the impact of embodied emissions, if you like, because this is the bit where we are mostly involved in the construction cycle, but also to look at those, how they play off against longer term impacts and what can be done with life cycle over time. So yeah, as you'll be aware, that transition is happening quite dramatically now with the shift from operational carbon impacts, if you like, around the energy use, and the embodied impacts are getting greater and greater. So this is where we're aiming to have our effect and draw our influence. So what does it look like for Skanska? And bear in mind, Skanska is a large global construction company, Swedish owned, operates across the Nordics, Eastern Europe, the US, and of course the UK. So a large company, and we're sharing information around this. But for Skanska UK, this is what our annual emissions look like. This graph shows what was our scope 1 and scope 2 in the green and red, and then it shows the impact of scope 3 emissions, which is 10 to 11 times the amount of sort of what a company would traditionally report, if you like, and the different columns show that difference over the last 10 years. To give you an idea, what it looks like for us is 12,500 tons saving a year, 3.5% reduction year on year to get down towards a net zero path. We're aiming to do that without ourselves going out and doing a mass offset. Offsetting will of course play a part in this, but we're looking to drive that through project by project approach, or with specific supply chain partners around specific controlled areas. So it's an approach that's developing over the time. No doubt your attention will be drawn to the fact that this emissions is going up and down. And there's a number of things that drive that. Obviously, the overall revenue we do in any given year, but also the nature of that revenue. So different construction projects, different activities have different carbon intensities, and also the effect of major projects with very carbon intense activities that happen within a certain year, for example, and how those phase and overlay. So whilst I want to look at a nice steady downward curve, the reality of measuring everything that's going on means there's actually more of an oscillation around a reduction, which is important to note. But just to sort of show you the measuring intensity as well as absolute emissions gives you an idea of how we're becoming more efficient with as we're growing. It's fair to say the Skanska's business in the UK is much bigger now than it was back in 2010. So there has been large reductions and improvements made by the industry as a whole, which is really encouraging, and I remain optimistic about how we can step up to this challenge. It is also worth to note that all information that's gone before is lagging, and often with embodied emissions and embodied activities, the design and procurement decisions have probably can happen up to 2-3 years in advance of the actual carbon happening on site. So there is a lag effect with these emissions. What does it look like? And this is important from an energy efficiency point of view. We have quite a reliance on the internal combustion engine. That's an important factor. We obviously have a huge reliance, a huge impact generated by the materials we use. So I think overall, what's important to note from this is there is no silver bullet. I think, as Simon said, when you're looking at it from a company point of view. And there's action needed across all areas. So I'm going to skip through two very quickly, which will obviously make a huge difference. The first one of those is the way we're delivering construction is improving hugely. So we will see much greater digital tools, software enabling us to make much better decisions, collect data better, be able to perform and understand the life cycle implications of materials, and also the way we construct as well, be able to control the materials we're using in a better way to help reduce impacts. Plant and equipment on site, definitely changing and set to change. Some of the pictures of some pilot studies we did with Volvo in a quarry that Skanska owns in Sweden. using electric autonomous dumper vehicles and that sort of thing. So I don't think they're coming to a construction site anytime soon, but they're definitely on their way. So it's something to watch out as we get much better controlling plant, making it much more, optimizing the use of plant much more, reducing idling, reducing waiting times between functions that the plant is needing to do for us. And of course, electrification, but it's not only electrification, there will be substitute fuels as well, with likes of HVO, or even potentially the role of hydrogen will play quite a role in changing the carbon impacts, but not always necessarily the energy efficiency. So a couple of case studies. Our new London office, we designed to sort of follow the developing at the time UK GBC net zero framework. We plan to use this to help measure and demonstrate what we've done with the building. I think it's best to describe it as a deep refurbishment. So we're using the existing frame, which obviously makes a big difference when you're looking at the embodied carbon emissions. But it was also, we were replacing all of the building services. So went to an electric heating strategy for the building, as a very efficient HVAC plant and equipment and strategy. But we also took steps to retain areas of the existing facade. So on internal atriums and things like that, we were able to refurbish and repair rather than replace sometimes for the sake of it. Retaining existing basement layouts and so on, just to really try and keep the carbon impacts down as far as we could. The life cycle assessment on this building, it's so 75% of it is in the operation, even though we've got, I guess that's a function because we did as much as we could to cut it down, cut down the embodied impacts. So the vast majority of this is relation to electricity use. Now we have a number of measures in place to keep energy management and control during operation. But of course, as well, we can use renewable electricity, and we buy REGO-backed electricity across our estates anyway. So in theory, that impact will come down. I think there's still a little bit to be done to make sure we're doing that as best as we possibly can. So it leaves us really with the impact or the liability of our refrigerants and our refrigerant use. It leaves us with the waste we generate, the water we use, and of course the backup generators and that sort of thing to look at as far as an ongoing requirement, and then investigate for how we are going to offset. Another example, and it was great to see, and there's some certain similarities. In fact, there's quite a few similarities with this and the case study from Germany that was shown earlier. And this is Skanska's involved with a Norwegian consortium called Powerhouse. And the aim of this is to develop energy positive buildings that are, if you like, a carbon proof for the future. So the initiative sets pretty strict rules on how it works, and it works within a quite a tight carbon budget for the whole life. And this carbon budget is reducing over the years, so future buildings have to work with less than the current buildings. And the aim is to design these buildings to be energy positive. And I think it was very useful from the definition earlier. That is a net positive across the course of the year. So this building, where it is quite a long way north in Norway, so it gets a lot of sun for some of the year and then not much for the rest of the year. And I think that plays into how it works. So the surplus energy here is stored. It's also supplied to neighbouring buildings, and there's investigation still ongoing about using it to charge the electric bus, that some of the electric buses that the city network has. So there's some great things that can come out of this sort of approach. The building itself is obviously, its whole orientation and angle is the whole PV roof. There are also PVs in some of the cells. You've got the whole, again, the atrium to get light into the center of the building. It's maximizing its shape and thermal mass as far as it can. It's actually using heat pump from the fjord behind that you can just see in the background. I think some interesting things though from this consortium that are sort of proving themselves as it's developing. I think this is the third, I think fourth building is just hitting now. Is that the consortium works with a very fixed palette of materials and technologies. So it's not looking for each project to appraise hundreds of new options all the time. It's working on understood technologies, and they work on what next outside of the projects that are happening, if you like. So it's sort of to reduce some of the options, if you like, but also some of the time that takes appraising these options for the projects in delivery. And they also set out with the carbon budget right from the start, so it's clear what they have per kilograms per meter squared. And as I said, that's ever progressing and ever reducing over time. So it's something they need to keep coming back to their palette of technologies and materials, and assessing and reviewing and developing on the downward trajectory. Appreciate that's a bit of a whistle stop, but that's me, and I look forward again to the discussion. So back over to you, Clay.
Thank you so much, David. That's brilliant. I'm going to bring in Victoria Kate now and make her a presenter. So just bear with me. There we go. Over to you, Victoria.
Great. So I'm going to take an even bigger step further back than David and share with you a little bit from the World Green Building Council about our global whole life carbon vision for a decarbonised built environment. My name is Victoria Kate Burrows. I'm the Director of Advancing Net Zero at the World Green Building Council, which is a global network of green building councils all over the world, including, of course, the UK GBC that many of you have mentioned already, and some of you on the call may be members of. So we have established a whole life carbon vision, which is actually becoming less of a vision and more of an obligation for the building and construction sector, that by 2050, new buildings, infrastructure and renovations will have net zero embodied carbon, and all buildings, including existing, must be net zero operational carbon. And that for 2030, new buildings, infrastructure and renovations will have at least 40% less embodied carbon with significant upfront carbon reduction, and all new buildings must be net zero operational carbon. And that's in reflection of how many more buildings are going to be built between now and 2050, those new buildings, the increased influence to affect design performance, and of course materials selection. But also it really helps to bring into scale how close 2030 is, because some design projects will take 5, 6, 7 years. And so suddenly 2030 being 9 years away, it's just around the corner, and we need to know how to design to these performance standards right now. So the whole life carbon vision brings together the concepts of operational carbon and embodied carbon, and we set for these a definition for net zero across each of those concepts and guiding principles that help ensure best practice is being delivered in terms of actually bringing these policies to life. For operational carbon, we set, for example, when we're talking about operational carbon, we really do mean in operation. So monitoring that use of energy over the course of a year, and also understanding where that energy consumption is coming from, where that energy generation is coming from, and the carbon emissions associated with that. Secondly, that we're reducing energy demand through highly energy efficient buildings to reduce energy wastage and improve things like comfort. And then in the third principle there is to generate the remaining balance from renewables. So as we've heard, on site where that's possible, but also building measures to decarbonize grids, off-site renewable energy sources, so that's really bringing in the net zero carbon definition that we need, because of course not all buildings can generate all of their energy needs on site. And then using offsets, as I think Simon mentioned, as an absolute last resort to achieve that net zero balance and phase the use of offsets out over time. And so similarly, we have a similar approach with embodied carbon, but I think today we'll just stick with the energy efficiency side of things. This is all super important because, as has also been mentioned previously, we are still building. And this graphic is showing that between now and 2060, the world's building stock is going to double. And the dark blue circles there are the numbers of the sort of millions of buildings that are existing already or that will be built over the next 10 years. And you can see that those hotspots are very much in sort of China and the north of America and within Europe. We are also going to keep building here, but the hotspots of new construction are going to be in Africa and India and Latin America. So we need to really be understanding what these best practice measures are for achieving high performance buildings and make sure we're passing those lessons on, how to make sure we can optimize that building stock that's going to be generated. And as has also been mentioned, how do we tackle the existing building stock? Because those blue dots will still be there in 2060, so we need to be tackling both. This is the Bullitt Center, which is an office building in Seattle in the US, in Washington State. It's a 5-story building, or 6, it actually goes into the basement, building in Seattle, and it achieved the Living Building Challenge Net Positive certification scheme, and it was first completed in 2013 and achieved that performance in 2015, but of course took several years through the design process to get to that point. And I want to show you this building because it has this cantilevered solar farm on its roof that you can just see the underside of there, and that extends outside the facade of the building. And this is helping to really demonstrate why energy efficiency is important to achieve these really high performance buildings that we've been hearing about today. The way that this building is built to ensure that it achieves net positive and amongst lots of other different sustainability impact criteria is to build it to incredibly high energy efficiency standards, to sort of passive house equivalent. And the way that the design team approached this was to know where the building was going to be positioned, be in situ, and calculate at 5 stories off the surface of the floor area how much generation capacity and potential there was from that building over the course of a year. And that provided the building with its energy budget, that then every single design decision for the fabric and the active systems within the building was set against to make sure that that building will remain within its energy budget. So not just making decisions on the basis of a financial budget, but an energy and carbon budget as well. So that means that the building is, over its lifetime, able to perform at net zero because it shouldn't exceed its budget. There's lots of other measures in place, and there's loads of information about it online if you want to take a look. But what's most interesting to me is this diagram here that shows how large that solar farm on the roof would have had to have been relative to its footprint if it didn't meet those passive house standards of energy efficiency. So the grey line is if it was built to LEED Platinum, actually couple of versions ago of LEED, but something that's actually very achievable within the American market to reach the LEED Platinum requirements for energy efficiency. So much more comfortable, but still a huge solar array needed. And so the difference between what can be generated on site and then the energy consumption of the building could be procured from off-site, and therefore it's net zero carbon, not net zero energy. But you can also see that the size of that solar farm is getting bigger and bigger if that building had been built to meet the local Seattle Energy Code, or indeed to be built as a typical building within the US, and therefore the massive role of both energy efficiency and policy to help drive these high performance buildings and reduce energy consumption. This was a program and a building that was able to be completed several years ago, and if they can do it then we certainly can today. So around the world, Green Building Councils are busy developing lots of different programs to help drive net zero buildings within their market and really drive us towards that net zero vision. And really depending on how the market is positioned currently will determine the scope of their frameworks. For example, we've already heard about the one from UK GBC on whole life carbon. In Germany, the DGNB certification scheme with Climate Positive has required LCA for more than 10 years. Some markets, such as in Brazil or India, are focusing for now just on the operational performance and certifying buildings that can achieve zero energy in use, so based on metered data. And then other markets, such as Singapore, Well, there's a real challenge for the amount of area, both on buildings and within the state itself, to generate enough renewable energy. Their focus is on driving super low energy buildings to make sure they're net zero ready in anticipation for a zero energy grid. And so we're really ensuring that energy efficiency is at the heart of these net zero programs. Each country, each national green building council will set different levels of performance depending on whatever the local market is used to, and it will help certify and verify that performance through the certification schemes that are available. And I wanted just to leave you with thoughts that, again, came out very recently. This is from an event yesterday that was held as part of the Race to Zero November dialogues for the lead up to COP26. This was the built environment session, and in one of the first segments of the day, we were discussing how we achieve a common vision across the entire building and construction sector in order to achieve a decarbonised built environment. And that was, of course, for both new buildings and existing buildings. And a little bit of a surprise to me, I have to say, that the lowest score for this poll that was taken was the least barrier is the lack of technical solutions and industry knowledge. So I think that's what tells us that, as we've heard from all of these fantastic companies presenting today, that the leadership is out there, the solutions are out there, we can be achieving net zero. But what's perceived at the moment, or certainly from the attendees of yesterday's event, was a lack of demand or understanding. So we as an industry have a huge role to play in increasing the knowledge and the sort of demonstration that this is achievable and we can do this at scale. The cost and the lack of financial incentives, so sharing stories and case studies like these to help really show that it's possible, and that over the lifetime of a project, net zero buildings, the perceived additional cost is actually much less. But probably less of a surprise, the greatest barrier that was recognised is the lack of policy and regulation, and that will follow industry leadership. So I encourage you to do what you can to follow your own net zero journeys, as the other panelists today have been sharing. So thank you very much for your time. I can hand you back now.
Thank you so much, Victoria Kate. That was really, really informative, and I'm sure there's loads we can pick up on, but I'm going to quickly try and make Peter a presenter so that we can go across to him for the final presentation.
So,
brilliant, that's great.
That's coming through. Hello, everybody. I thought I would just start. I was going to try and contextualize things a little bit and then look at one case study. But I thought where I'd start was actually not by looking forwards, but in a sense by looking backwards. This is Wessex Water, and this is a building that we completed 20 years ago this year. And partly to celebrate that milestone, it was rated as the most environmental office building in the UK at the time of its completion, and it's still got exactly the same chief executive is based in the building. So we've been back over the last year with Bureau Happold and started looking at the building again and looking at the POE of the building. And interestingly, if the gas boilers of this building were changed to air source heat pumps, it would constitute net zero carbon under the UK GBC framework. And the point of saying that is, I think there's often an emphasis or a lens placed on technology and new techniques. And actually, a little bit like Victoria was just saying, a lot of the techniques we already have. You know, if a building from 20 years ago that is unaltered could be net zero carbon today simply by changing its boilers, then a lot of those lessons, which are quite simple, are already there. And we don't have to learn quite as much as I think is sometimes thought. And actually the prospect isn't quite as daunting, certainly not for new buildings. Now, just to put the whole thing in context, really, we've long used science-based targets and the science-based trajectory to try and understand where we are. And this somewhat precedes the UK GBC targets for energy use coming out and some of the work that is still going on embodied carbon. But broadly, a science-based target is looking at a trajectory that keeps us to 1.5 degrees of warming under the Paris Accord, and it follows the dotted red line on this graph. And ever so roughly, a science-based trajectory is something akin to about 4.2% year-on-year reduction in carbon emissions. I mean, that is the least that we need to do. So ideally, we'd be well under that. So if we move to, say, the operational energy intensity of office buildings, the current average of in Britain of somewhere just north of 200 kilowatt hours per meter square per annum, and we begin looking at science-based type trajectories down to a Paris-proof target of just over 50, then we get something akin to those UK GBC targets as they're going every 5 years, incrementally stepping down. And the interesting thing there is once we begin to blend in, this is a series of projects that we've worked on over a number of years. Some of those projects, including Wessex, are already getting pretty close to some of those targets. Now, the two projects there, Wessex and Cambridge, highlighted in blue, those are naturally ventilated office buildings. And then the other Pancras Square, Potter Row, those are mechanically ventilated displacement ventilation office buildings, and Grosvenor Gardens is a refurbishment. And I think in a way, you begin looking at some of the new builds, particularly if we move to natural ventilation or mixed mode, as was previously mentioned, we are within shouting distance of hitting those Paris-proof targets. The really big conundrum is the existing building stock and how we deal with that. And then the project that I'm going to come on to talk to in a little bit of detail is Lavington Street, or Timber Square as it is now known, which we're working towards going onto site with Landsec down in Southwark at the moment. And its overall targets are on that trajectory, albeit there's a lot of work going on in the background to try and bring that even further down. And on the new build components, the interesting thing there is once you begin to understand the landlord and the tenant split of energy consumption, and the totals are still looking relatively high, even though the landlord components are, we're getting tolerably close, and in fact now have a plan for getting to the 2035 targets in immediately. But the rest of that makeup, really over half of the difference between the landlord and the total is on-site IT usage and on-site servers and the associated cooling with those. And so there are huge strides required, not only in the way that we design buildings, but actually in the way that they're occupied, and that's going to be the biggest factor. And I think that's probably one of the unknown and understood factors going forwards. So this is a graph that just takes a fairly typical London office building and looks at operational carbon emissions annually and embodied carbon emissions and compares them on one graph. And the red is ongoing operational carbon emissions, and the white bar here is the embodied carbon emissions that are emitted on day one or even before the building is occupied. And if we look at the cumulative operational CO2 emissions of a building such as this, even over 30, 40, 50 years, it comes nowhere near the day one embodied carbon of a building such as this. And of course, that white line across the top, that doesn't include any repair, it doesn't include any maintenance or refurbishment. That is just the carbon that is emitted before that building is inhabited. So I think if there's a lesson out of this, is really that embodied carbon, the existing building stock, are really where the difficulty is, and not to underemphasize the role of new buildings or the difficulty of that, but we are within shouting distance really of being able to deliver quite convincingly net zero carbon new buildings. And so when we then take embodied carbon and apply a similar science-based trajectory to the current average of somewhere just north of 1,000 kilograms per meter squared, we get to a target in 2050 somewhere around the 200 mark, which is where we need to get to. And again, if we blend in a series of fairly typical good practice buildings, they're pretty close to that trajectory. And then Lavington Street, which is what we're working on at the moment, even including sequestration, there is still a lot of work to do on that. And the targets that we're working towards now are somewhere sub 400, but even the difference then between sub 400 and getting down to 200 kilograms per meter squared is really quite marked. There's quite a lot of work to be done to get to those levels. And Grosvenor Gardens is the new components of a refurbishment project. So there's still a lot of work to do on those kinds of things as well. And then this is just moving on to look very briefly at Lavington Street, or Timber Square and Lavington Street, which it combines a whole series of these varying strategies. It's half of it is a complete new build and half of it is half reuse and half extension. And it is looking at different types of materials to what we normally use in office buildings in London. So it's mostly cross-laminate timber on a steel primary frame. And that results in a building that's about 20 to 25% lighter than is typical for this kind of building, which has some benefits in foundations, etc., and also enables us to build on the top of existing buildings. And so the construction is fairly straightforward. A lot of what we've been looking at on this project has been missing out finishes that we don't think we need. And so things such as ceilings, trying to have everything as self-finished, so there's no plasterboard as far as possible in the cores, there are no ceilings in the back of house areas, looking at the type of flooring materials, so trying to miss those out, but then also just having exposed steel primary frame on a 6-meter grid and then cross-laminate timber planks. And then looking as well at the servicing strategies going forward. Can it be mixed mode? How well shaded is it? And the varying shade servicing options from 4-pipe foam cores to mixed mode to chilled beams as upgrades that are possible. But quite a lot of the real changes that will come in a building such as this will be from the tenant and from the IT loads. And then we hope as well as driving and buildings that consume less energy and that consume less carbon in their construction, using warmer materials, having finishes that are simply not installed, so the building has a much more raw and more visceral quality, more natural materials and more reused materials. I think a big part of our hope is not only is this a more environmentally benign future, but hopefully a slightly more humane and a more pleasant and a much warmer, more characterful one as well. And we hope that from that you get buildings that are also much nicer and with much better connection to outside and more use of external space within office buildings. And then one of the final pieces in this really is also just get a bit like Wessex, getting those basics right. And so as we move around the building, its glazing ratios change quite considerably. They change as you move around from north to east to south, and they also change as you move up the building. So it gets more solid as you move up the building. It changes from glazing ratios of almost 80% on the north facade to glazing ratios of less than 40% on the upper portions of the south facades. And then this is just some views of those exteriors, and you can just begin to see the public realm, the reused buildings, some of the roof terraces, and then quite subtly the way that the glazing ratios alter as you move around and you move up the building. So thank you very much.
Wonderful. Thank you so much, Peter. I'm going to invite everyone to come back with their webcams just for the Q&A session. Obviously, we're getting quite close to the hour now, so it might be that not all of the panel can stay for all of this, but I just felt, given the volume of questions that we've had in, it only seems fair to try you on some of them. So I'm going to start off with a point a couple of the panelists made about ICT within buildings, and one of our audience is just asking about how is it possible to accurately forecast for the increased use of power for ICT equipment, and I suppose that's a really difficult thing to do. Are there any theories around that?
Well, if I come in on that, I don't think there will be increased power usage for IT loads. We know that we install far too much power already. It's hardly ever used in buildings. One of the biggest issues that we have on office buildings, certainly in the UK, is over specification of M&E, over specification of small power. And if you look at the way that IT is changing, it's becoming much more domestic in scale. So, just last week, Apple moved towards ARM processors. That's all day. I mean, it's at 12-hour batteries. Looking at video playback, I think it's very feasible that we will be in a position where you almost don't need raised floors anymore. And moving off-site, the biggest load is on-site servers, and moving servers to the cloud, which a year ago would have seemed fanciful probably, but now is just going to happen. That massively reduces carbon emissions, just because big server farms are a lot more efficient and centralized. So I think the power consumption within buildings is going to plummet. And it isn't simply a case of offsetting that power load to elsewhere. That power load gets a lot more efficient elsewhere. So I can see a time when you have 5G connected ARM processors in computers. You don't have most of the most of the infrastructure in the back of office buildings for that. So I don't think we're going to have more power usage for IT in office buildings going forward. Quite the opposite, in fact. And we can move to something that is more akin to a much more domestic setup.
Okay, Simon,
one of the things you mentioned, which is really important, is the associated cooling. So a lot of MEP, as you said, is oversized at the moment. I'm working with the BCO at the moment on the net zero carbon strategy, and we're looking to change guidance to enable the M&E to be sized significantly smaller. So a lot of people at the moment try and design to the BCO guide. If we can reduce the size of that, it means the plant's much more efficient and it will be running a lot lower. Again, it's also hugely about engagement. So working with speculative office developers at the moment, it's educating and informing tenants what IT to procure and how to do their procurement strategies going forward. And as Peter indicated, moving to the cloud is vital to that.
Okay, I'm going to move swiftly on to another question. This is from Carl, saying one of the challenges he thinks is that the energy savings and costs that are saved generally by the tenant, whereas the building owner and the financier face the upfront cost. Do we have a bit of a structural problem there in terms of who has to pay for it and who gets the benefit?
Do you want? If
Go
anybody,
for
I'll go for that. I think it's been a fascinating 18 months just with how things are changing. And I remember before the financial crisis thinking sustainability was just coming mainstream, and then it just got obliterated by the financial crisis. And I feared at the beginning of COVID that would be the same. And it absolutely, in my experience anyway, it absolutely manifestly hasn't been. And I think now the real change is sort of big North European pension funds, things like GRESB, the Global Real Estate Sustainability Benchmarking Index, that is actually making it easier to raise finance on the basis of more environmentally benign buildings. So I think it may well be that the financial savings are for the tenants, but there will be a point very soon you will not be able to let a net zero carbon building. And it's worth looking, if people haven't, at JLL's report, The Value of Sustainability, that was released in May. Yeah, there's 12 million square feet of office space in London that's occupied by companies that have lease events before 2030, that have net zero carbon targets for 2030. That's a huge amount of office space. They ain't going to be moving into poor buildings. There's going to be flight to quality, as Landsec have referred to it as. So I think the pressure is really on developers to do that. They're not simply not going to let bad buildings in the future.
I think
it goes further than that. It's securing the funding to sell as well. So we're working with quite a lot of developers now who are unable to sell because the people they were building for, now the hedge funds and pension funds that they build to have such stringent ESG requirements, they're not getting funding, they're not being able to sell their properties. You could end up with stranded assets. So I completely agree with Peter. The last few months, 6 months to a year, the financial markets have moved on significantly, and it's really driving through the entire industry. And the other big one with GRESB is the Task Force on Financial Disclosure, which is set up by the Bank of England's Mark Carney and now endorsed by all world banks, and may become mandatory for finance going forward, which requires reporting the risk from climate change and mitigation measures that organisations are doing. So it's not really a question of can you afford it. The question is, can you won't be able to afford not to do it.
Yeah, Marco, sorry, you wanted to come in on that as well.
I think we actually see exactly the same direction what Peter mentioned. We have more and more corporate clients who have sustainability reports and their own targets, and they won't move into an asset which doesn't fit to their sustainability strategy. And at the same time, we also recognize that there are more and more financial tools and frameworks which compensate for that. You see the European taxonomy right now. This will be a huge change in the next years. It will change the entire game, and it will take into consideration also embodied carbon and so on. I think this will be a game changer in the future, and we recognize that already now with the demand for green bonds. So we have more and more investors who want to put their assets into green bonds, and to do that, they need to qualify for that. And that's only the top 15% performance buildings in the market. So I think financially it will be definitely necessary to look into zero carbon if you want to have a sustainable and future-proof asset portfolio.
Okay, I don't want to overrun too long, but there are a couple of other questions that I just want to try and fit in. One was specifically targeted at David. I'm not quite sure, maybe everyone can feed into this, but it was asking for any positive examples about innovation to do with low carbon materials that you might be looking at. Is that something?
Yeah, and of course, to be quite brief, just tracking all the developments around concrete and cement replacements. Trials going on with the different suppliers there, but also through our Swedish division, that Swedish business unit that make concrete themselves as well. So we're tracking that, tracking asphalt. Again, developing an asphalt solution for to be net zero through Sweden, and looking at the introduction of magnetite and different metals that mean the asphalt can be heated in different ways with microwaves and so on. So lots of development going on, building quite a lot across Skanska Global with timber. We've got our own prefabricated housing solution with in JV with IKEA, on which is all prefabricated and using timber. So the answer is yes, and I'm really optimistic about materials. I think it follows the same thing with energy efficiency, is that the technologies are becoming more and more available. There are slightly bigger barriers to getting them into place. You have to hit specifications. We've got to know these things perform, and quite rightly, we've got to take the time to make sure we do get the use of the materials right. But yeah, big changes coming in material technologies, and I think it's a really exciting area to be involved with as a construction engineer. You know, it's not a case of we know what we can build these days. You know, it's now a case of doing it with less or with different exciting methodologies. So.
Okay, great. Just time for one last question. This is from someone in the audience who's got a building on their hands which is grade 2 listed building, and I think this speaks to one of the problems that the panel was talking about in terms of refurbishing existing buildings is probably the biggest headache, because a lot of the solutions are for new builds. But you know, his point is we want to do the right thing, but we fear that it will cost us far too much to do. Do you see a lot of building owners in this sort of predicament, and what hope is there that we're going to make some inroads on the sort of refurbishment front? I know that's not specifically our topic today, but energy efficiency for existing buildings is a huge challenge.
Existing buildings and heritage is probably the biggest challenge within that. There's a number of working groups at the moment. So CIBSE Heritage Buildings are looking at guidance for that, because there's always problems with moisture, with insulation, and how you actually do it. So it really needs to be sympathetically done with experts. There are a number of experts in net zero carbon who work with heritage buildings, but it's not impossible. Like we were asked if we could make the Tower of London net zero carbon recently, so we're doing some reviews on that. It's actually quite a low energy building to start with. So there's always something that can be done. You just have to be really careful with the fabric and get someone who understands moisture transfer through some of that. But the systems in terms of heating, you can move away from fossil fuels. There's always stuff that can be done, and there's always solutions.
Well, I think that's... Sorry, Kate.
I actually spent the first lockdown renovating an apartment in a grade 2 listed block myself, and what I would really encourage people to do is exactly what Simon said there, is to speak to experts about it, because we couldn't use the recommendations that were on our EPC that said, you know, upgrade to double glazing or install a ground source heat pump on a first floor flat, because it's just impossible for that type of building. So you really do need to seek that expert advice and think about what you can do now that is cost viable. And as we've been talking about the solutions that are coming more and more viable and more solutions becoming available, look at what you can do now, but also think about it in terms of a long-term strategy so that you can be upgrading over time, not just what's available today.
Okay, well, look, I'm going to draw a close there, but there were so many other questions that I would have loved to cover. But thank you all so much for sending your questions in. Thank you very much to my panel, Peter, Victoria, Kate, Marco, David and Simon. Thank you for your time today. Sorry for overrunning a little bit. Just a reminder to our audience that if you have missed any of this, you can get it on our website on a replay. So hopefully that will be useful to you. But I think this is obviously an enormous topic, one that we will come back to. Thank you very much to Dries and Summer for supporting this webinar. And that's it for today, but hopefully we can reconvene and pick up a lot of these really important threads, because it's an ongoing discussion. So thank you very much, everyone, and goodbye.
Thank you.
Right.